Hi, good afternoon to everyone. This is Shiv Kumar Shah, and welcome to the Gate Mentor Academy. So, today we are going to discuss fluid kinematics. In fluid kinematics, we have a subtopics. So, first of all, we will understand that what is actually kinematics. So, in this topic, we are basically dealing with motion of fluid particle. Dealing with motion of fluid particle without forces. So motion of fluid particles means we will discuss here the velocity of particle, next acceleration, and third rotational velocity. So these are the three important, that is a motion of the fluid particle. With the help of this property, we will discuss that how to find out the acceleration and what are the types of acceleration are there, and how you find out the rotational velocity for 2D and 3D. And we'll check that here velocities in different axes. So first of all, here the velocity would be the function of space and time. Similarly, the acceleration would be the function of space and time. So the velocity of a fluid particle in a space is represented by a three-dimensional axis. This is x, y, and z. Along x-axis, let us consider the velocity of fluid particle is u. Along y-axis, v. Along z-axis, it's a w. So at any point, I am assuming in a space. At any point, let's say that that point is P and it is named as x1z. We will discuss that how will you find out the velocity of a fluid particle which is passing through the point P. So we can represent the velocity in a space is x u v w. So the velocity in a space is written as ui plus vj plus wk. So here, first of all, we will study the fluid particle, study the behavior of fluid particle. So the behavior of a fluid particle is studied by two approaches. The first is Lagrangian approach. Lagrangian approach. Lagrangian approach says that we will focus the behavior of a particle in a space. That Lagrangian approach is nothing but let us consider a space is there, and let's say that these are the fluid particle which is having a path, and we will see that how the fluid particles are varies in terms of velocities, acceleration, and angular velocity also. So the Lagrangian approach mainly focus on space. We focus in space of a fluid particle. So we can say that in a sentence, observation is made through motion of fluid particle in a space. Observation is made through motion of fluid particle in space. But the opposite of Lagrangian approach is Eulerian approach. Eulerian approach. And we will apply a Eulerian approach only to discuss the velocity, acceleration of a fluid particle. And what is actually Eulerian approach? The Eulerian approach is a point method. Point method means we will check that, let's say that this is a space, and along that there are the fluid particle which is having a regular path. So we will consider here at a one point. Let's say that this is the one point is there, and we will see that how the velocity and acceleration is varying with respect to time and space. So this is a point. So we can define that observation is made. Yeah, we can say that properties of a flow field are described. Property of flow field described by a point selection. By a point selection. We will assume a one point, let's say that x, y, z and t, and we'll check that here how the velocities, acceleration are varies. We'll consider the one point, but we saw that in Lagrangian approach means it's a space, and in a space we can consider any section. So Lagrangian approach is also a section method, means we'll consider the one section and we'll see that how the fluid particle is varies. So let's say that the fluid, let's say that the velocities of a fluid particle in a 3D is represented by ui plus vj plus wk, where u is a velocity of a fluid particle in x direction, and this is the velocity of fluid particle at a point. It's at a point p, and it is given as, let's say that this is the 3D and this is the point p, and along that this is the path of a fluid particle and it's a x, y, z. So we can say that along x-axis the velocity of a fluid particle will be u, and it is given as limit dt tends to 0 ds by dt. Similarly, the velocity in y direction is given as limit dt tends to 0, it's a dy by dt. It's a dx, not ds. And along w, it's a limit dt tends to 0, it's a dz by dt. So it's a rate of change of distance with respect to time is here velocities, and we'll check it here that whatever the u, v and w are the function of, yeah, r could be the function of space and time. That you remember that it could be a space and it's a time also. So, and after that we will discuss that this is called here, whatever the path traced by the fluid particle is here called a path line. So path line is a same for steady flow, and that is also called a streamline. So we will discuss here, this is the three important subtopic. That is the first of all is a streamline. What is actually streamline? Next is a path line, it's important, and another one is a strict line. They are the three important parameters. So we'll discuss here one by one. So the first thing is streamline. So here I will give you the definition for streamline. It is an imaginary line drawn. This is a imaginary line. It is a imaginary line drawn in a flow field such that tangent to the streamline, tangent to the streamline gives the direction of velocity of flow, direction of velocity of flow of what? Fluid particle. This is a very important. Means if you are assuming that, let's say that a two-dimensional diagram, x, this is the y, and I am assuming that, let's say this is the point P, and this is I am calling as a streamline. And if you draw a tangent on the streamline, this tangent will give the velocity of that fluid particle. And let's say that this tangent is making an angle of theta with x-axis. So we can resolve it. This one will be here v cos theta, and the perpendicular to that is a v sin theta. So here I can say that along y direction, the velocity will be v cos theta, and along x direction, the velocity will be, okay, it's a v sin theta. It's a v sin theta, and this is here v cos theta. If you divide these two, you will get it here v by u must be equal to tan theta. And tan theta indicates what? It indicates that slope of the line. Which line? That line. And that slope is given as it's a dy by dx. So I can say that it's a dy by dx is equal to v by u. So from here we can say that dx by u must be equal to dy by v. And this is the here streamline equation. This is called streamline equation for 2D. If you write down for 3D, it will be here dx by u, dy by v, and dz by w. So this is the streamline equation for 3D. So this is here important for a gate point of view. Every year they are asking 1 mark question from streamline. Next, we will see that what could be the properties of a streamline. So the property here we can say that if you draw a so many streamline, like this is one streamline, this is another streamline, this is another streamline. So here we can say that the streamline never intersect each other. This is the property of a streamline. Why they never intersect each other? Because if you draw a perpendicular to that streamline, there will be a no flow to the perpendicular to the streamline. And if there is a no flow, it means this streamline must be in a parallel condition. So we can say that the first important point is no two streamline intersect each other. Second, there will be no flow. There will be no flow across or perpendicular to streamline. Cross or perpendicular to streamline. So these are the here properties and the equation of streamline and definition we have described. Next, we will see that here path line. So path line is a simple definition. It is a path traced by the fluid particle at a different instant of time. It's called here path line. So path traced by a fluid particle at different instant of time is called path line. Like I'm assuming that let's say that this is the fluid particle and it is at t time. So after some time, let's say that the fluid particle reached at some other point. So it will have a some different time. That is a t plus delta t. Again, t plus 2 delta t. Again, let's say that after some time, it become here t plus 3 delta t. So join that all the point and whatever the line you will get it here, that line is called here path. So let's say that this is the A, B, C, point C and D. So these are the here, it's a path line. We can mark it by a different color here. Let's say that yellow marker. This is the point, these are the point, this is the point. Same way next, another one is a strict line. So what is actually streamline? Let's say that this is the one streamline, this is another streamline, this is another one, this is a streamline equation. So there must be, and this is also called a path line. So let's say this is the one point is here, and I'm assuming that another point is here. So let's say that this is the point, and let's say that here, and another point I'm assuming that, let's say that here. So if we join the point, you will get a line. If you join a point of a different streamline, you will get a line, and this line is called here strict. Means we can write down in terms of definition, it is the locus. It is the locus of point of, it is a locus, just a minute. It is a locus of a fluid particle. Locus of a fluid particle moving in a different streamline. This is a streamline. So the one of the important point to remember that for steady flow, streamline, path line and strict line are same. Means there will be only one line, and that are called here all the three things, that is stream, path and strict line. So what is actually here steady flow, uniform flow? We will discuss here first of all. Then we'll move it to that continuity equation. So we'll see that here types of flow. Then first is a steady and unsteady flow. So here steady and unsteady flow, that always will be with respect to time. Means properties of a flow like velocity, acceleration do not change with respect to time. It's called a steady flow. So properties of a flow like velocity, acceleration do not change with respect to time. They can change with respect to space, but with respect to time, it should not change. It should not change. That is called a steady flow. That is a steady flow. Means if I'm assuming that it's a time like let's say that whatever the time is here, like now it is a 1 o'clock. At 2 o'clock, the velocity should be same. 20 meters per second, it should be 20 meters per second. That is your steady flow. But if it is changing with respect to time, it's called unsteady flow. It's a unsteady flow. It means dv by dt must be equal to constant. This is for steady flow. Or for unsteady flow, dv by dt, that should not be constant with respect to time, or acceleration with respect to time, that should not be constant. These are the comes under the unsteady flow. Next, we will see that here uniform and non-uniform flow. Uniform flow means, let's say that this is the pipe is here, like this is a 1 meter, this is the 2 meter, 3 meter and 4 meter. So at this point, let's say that the velocity is a 2 meter per second. At some point here, the velocity is here 2 meter per second. Here also 2 meter per second. Here also 2 meter per second. That is called a uniform flow. Uniform flow means there will be no variation of velocity and acceleration with respect to a space. As for space, there will be no variation with respect to a space. Like acceleration dA by dc, that should be constant with respect to space. That should not vary. Correct? But if it is varying with respect to a space, that is called a non-uniform flow. So if it is a non-uniform flow, means अगर वो space के साथ constant नहीं है velocity या acceleration constant नहीं है, these are the called a non-uniform flow. That is important thing. Keep in mind here. Next, हम लोग discuss करते हैं. Another type is there like a laminar flow. Laminar and turbulent flow. Turbulent. So हम लोग यहाँ पे बहुत अच्छे तरीके से जानते हैं कि क्या होता है एक्चुअली लैमिनार एंड टर्बुलेंट क्या होता है, बट हम लोग डिस्कस करते हैं लैमिनार फ्लो क्या होता है. अगर फ्लूइड पार्टिकल इज मूविंग इन ए स्ट्रेट पाथ और इन ए यूनिफॉर्म वे, देयर विल बी अ नो zigzag. So laminar is only possible for steady and uniform. अगर फ्लूइड पार्टिकल जो भी है फ्लूइड पार्टिकल अगर मूव कर रहे हैं वेल डिफाइंड पाथ, दैट फ्लूइड पार्टिकल moving in a well defined path, it's called a laminar. और अगर velocity constant है then only the fluid particle will move in well defined path. So the laminar and turbulent flow, that is recognized by here a Reynolds number. And the Reynolds number is here, it's the inertia force upon viscous force. And if you drag that, you will get it here, rho v d by v. But rho is the density, v is the velocity, and d is the diameter of the pipe. So this is for here pipe. So अगर Reynolds number अगर 2000 से less आता है, that is for pipe case, it's a laminar flow. Or if the Reynolds number is greater than 4000, it will be assumed as a turbulent flow. And turbulent flow means what? The fluid particle moving in a zigzag way because they have a random velocity. Particle moving in a zigzag way means it's a non-uniform and unstable. दोनों में से कुछ भी हो जाए, it will be a turbulent. And अगर Reynolds number दोनों के बीच आता है 2000 से 4000, इस टाइप को फ्लो को बोलते हैं हम लोग मिक्स्ड फ्लो. And mixed flow is a mixture of laminar plus turbulent. Next हम लोग के पास है rotational and arotational. That is the fourth one. Rotational and arotational flow. So rotational flow means what? तो अगर कोई भी fluid particle है, like let us assume that this is the fluid particle which is having a path line is this one, this is the path line, and let's say that here. And if this fluid particle is moving in a straight way and it is also revolving about its axis, is known as rotational flow. Rotational flow means it should have a translation motion plus rotational motion. दोनों होना चाहिए. That should be a rotational flow. So rotational flow के लिए हम लोग use करते हैं formula angular velocity. We'll check that here with the help of angular velocity whether they are in rotational flow or irrotational flow. And irrotational flow means that particles should not move about their own axis. It should only translate. It should have a translation motion, no rotation motion. Rotation motion नहीं होना चाहिए, only translation. बस इसमें दोनों होना चाहिए. The fifth one is here compressible and incompressible. So हम लोग बहुत अच्छे तरीके से जानते हैं compressible and incompressible flow. Compressible means if the densities varies with respect to point to point. If the density is not constant, that is called compressible flow. Incompressible flow means it should be constant throughout. It should be constant throughout the pipe. It should be a constant value. तभी इसको बोला जा सकता है incompressible. Incompressible means like a water is incompressible or any type of liquid is incompressible, but gas will assume as a compressible fluid. Gas is here, it's a compressible fluid. Okay, so next we will see that continuity equation. For pudding. Continuity equation is also says that it's a conservation of mass. That mass is conserved through. If I'm assuming that, let's say that the nozzle is here, and this is a section 1 and this is section 2, and the fluid particle is moving here, having density at this point is rho1, area is a1, and the velocity is a v1 at section 1. Similarly, rho2, a2, and so continuity equation says that for a steady flow, the rate of change of mass flow rate with respect to time, it must be equal to 0. Mass flow rate, rate of change of mass flow rate with respect to time is 0. And the mass flow rate is represented by m dot, and it is given as rho into v. And rho is kg per meter cube, and q is called here discharge. Meter cube will cancel. It's measured at 80%. So this q is named as here discharge. कितना amount of liquid discharge हो रहा है to a pipe. So if you integrate here, you will get here dm, and m dot must be equal to constant. And constant means the mass flow rate at inlet must be equal to mass flow rate at outlet. So it's given as rho1 a1 v1, because यहाँ पे discharge का formula होता है area into velocity. That is area of cross section. That is a cross sectional area, and the velocity of fluid particle. So the mass flow rate at inlet is given as rho1 a1 v1 must be equal to rho2 a2 v2. And if I am assuming that for incompressible flow, the density must be equal to constant. It means you will get a1 v1 must be equal to a2. And finally we can say that a into b must be equal to constant. So अगर यहाँ पे incompressible flow है, so that area must be inversely proportional to velocity. Or अगर velocity of fluid particle if it is increasing, it means the area of the cross section must decrease. Or the velocity is decreasing, it means the area is here increasing. That is it. And the product of area into velocity is named as discharge. Because कोई भी पाइप के थ्रू अगर फ्लूइड पार्टिकल डिस्चार्ज हो, वो amount of discharge हमेशा constant है. It won't be that area into velocity. So we can write on into a word area into velocity must be equal to velocity. So ये है continuity equation for 2D. अगर हम बोलते हैं continuity equation for 3D क्या होगा? Continuity equation for 3-dimensional flow. So we have to check it here. 3-dimensional flow means, let's say that here 3-dimensional I am going to consider space. Along x direction it's a u, along y direction it's a v, and along the z direction it's a w. velocities. So यहाँ पे हम लोग consider करेंगे, let's say that length is dx, dy and dz. So here I will consider that this is here x face. I will mark it by yellow color. This is here x face. This is the y face. No, x face is this one. This is here x face. X face. This is actually here z face, and the y face is top part. This is the y face. ये y face है. तो यहाँ पे हम लोग कंसिडर करेंगे how much there is a mass product, there is an inlet mass product, outlet. M dot in, M dot out. इधर से भी हम लोग कंसिडर करेंगे M in, M out. And here also M in, M. So हम लोग देखेंगे कि net gain कितना होगा if the fluid particle or if the mass product is happening through all the sections. So we are not going to derive it, but I am going to write down the equation with the help of principle that is given as three-D equation. 3D. It's a dou into rho u by dou x plus dou into dou v divided by dou y plus dou into dou w by dou z plus dou rho by dou. This is a three-dimensional continuum equation that is valid for compressible flow, uniform flow, non-uniform flow, we can say that. That is all types of flow. So it's a compressible, non-uniform and unstable flow. Unstable flow. क्योंकि अगर हम uniform flow बोलते हैं, then there is a space there, it will be constant. It should be valid, should be for non-uniform. Compressible, yes, density is in, and unsteady means there is also time is there. अगर steady बोलते हैं तो ये zero हो जाएगा. It should be unsteady. So यहाँ से हम लोग derive करते हैं. अगर हम लोग case 1 लेते हैं, that is called incompressible flow. Incompressible flow. No, first of all, I will take it here. Steady flow. Steady flow. Then, with respect to time, it should be equal to 0. Dou rho by dou t is 0. Then you will get it here. Rho u by dou x, rho v by dou y, rho w by dou z. And case 2 for incompressible flow. Incompressible flow means the density must be equal to constant. So dou u by dou x plus dou v by dou y plus dou w by dou z must be equal to 0. Yeah, that is an incompressible. So this is your final equation. This is called dou u by dou x, dou v by dou y, and dou w by dou z. This is the continuity equation for 3D, and this is a valid for steady, incompressible, irrotational also. And it's a non-uniform flow. These 3 cases. So इसको हम लोग general form में लिख सकते हैं. The general form of continuity equation is given as d rho by dt plus rho into del dot y is equal to 0. ये general form of continuity equation, that is in term of vector. Sometimes they will ask this one. This is also keep in mind that previous one, इस equation को हम लोग लिखे हैं vector form. इस equation को लिखा vector form. Now we will see that some question based on that. We have some questions also. We'll check it. See, look at here. That's given as question number 1. The flow is represented by V is equal to AX plus AYJ, where A is a constant. Then find the equation of streamline passing through the point 1, 2. The streamline equation पूछ रहा है, and it's for 2D flow, means हम like लिख सकते हैं, that is so dx by u must be equal to dy by u. This one is given as u, and this is the electric, because we will particle that is given as y plus bj. And if you compare, u will be x and the v will be ay. So अगर यहाँ पे सब्स्टिट्यूट करते हैं, then dy by ay, a get cancel. तो उसके बाद हम लोग को streamline equation फाइंड आउट करना है, तो इसको मुझे इंटीग्रेट करना पड़ेगा. dx by x must be equal to dy by y, and this will be ln y must be it's ln x must be equal to ln. If the two terms are in ln, the third term will be also in ln only, and it's a constant. So if you bring it here, ln, this will be x by y must be equal to ln c. ln get cancelled, x must be equal to y. उसके बाद पूछ रहा है the point it must pass through the point 1, means x should be 1 and the y should be 2. c must be equal to 1. c का वैल्यू यहाँ पे पुट कर दो, then you get it here c by 2. No, it's a y by 2. So it will be 2x minus y must be equal to 0. ये मेरा streamline equation. So 2x minus y means the option number is right. अगर 3D velocity दिया हुआ रहेगा, so we will equate with one more term, that is a dz by w. And वहां से हम लोग को दो streamline equation मिलेंगे, and those two must be constant. चलो next है हम लोग के पास next question. Velocity component in x and y direction are given, that is this one and this one. Then find the value of lambda for incompressible flow. देखो हम लोग इनकम्प्रेसिबल फ्लो के लिए एक फार्मूला ड्राइव किए थे, कंटिन्यूटी इक्वेशन फॉर 3D. कंटिन्यूटी इक्वेशन फॉर 3D, and it is given as dou u by dou x, dou v by dou y, and dou w by dou z must be. Only two velocities are given. इसको नेगलेक्ट कर दो. dou u by dou x, इसको डिफरेंशिएट करो and write down here. Differentiate this one also and write down and equal to 0. You will get the lambda. So if you differentiate this one, dou u by dou x, you will get it here. With respect to x means the y term must be constant. So it will be here lambda y cubed I minus with respect to x means it should be 2xy. Similarly ये v है, so यहाँ से हम लोग को फाइंड आउट करना पड़ेगा dou v by dou y. With respect to y means the x term must be constant. So y square का differentiation it will be 2y. So it will be 2xyi minus 3 by 4. It will be here. It will be here 3 by 4 and y4 is a 4y cube. So here 4 get cancelled, and if you substitute the value here, that is a lambda y cube I minus 2xy plus 2xy I minus 4 get cancelled, it's a 3y cube. That must be equal to. Here the one mistakes are there in the question, that I should not be there because यहाँ पे velocity component दिया हुआ है. So velocity component means it should be coefficient of I and j. तो यहाँ पे मिस्टेक है क्वेश्चन में, आई नहीं रहना चाहिए, सो आई विल इरेज इट फ्रॉम हियर आल्सो. Right done. Now it will be here. Okay, so this 2xy plus 2xy get cancel, and यहाँ से y cube कॉमन निकालते हैं, lambda minus a square, then the lambda must be equal to 3. So option number is right. Similarly, another question यहाँ पे देखते हैं, उसे दिया हुआ है, the velocity of a flow is given by v is equal to, this is there, and this is u, v, and that is a velocity along x, y, z direction. And the density is here also varying with respect to t, and it is given as rho is equal to rho naught e raised to minus 2. In order that mass is conserved, find the value of lambda. So mass conserved means it's a continuity equation. So lambda value find out करना, it means I will write on the 3-dimensional equation with respect to compressible flow. That is a dou rho by dou t plus dou rho u by dou x, dou rho v by dou y plus dou rho w by dou z. क्योंकि यहाँ पे डेंसिटी भी वैरी कर रहा है with respect to. So if you differentiate it here with respect to t, rho naught is constant, e raised to anything is e raised to minus 2t into minus 2 t का 1 है प्लस रो है, तो रो यहाँ से तीनों में से कॉमन निकाल, टेक द रो एज अ कॉमन. Now it will be here dou u into dou x, dou v by dou y, and dou w by dou z. It will be. So this is actually, this is also rho, and here also rho. So rho you take out the common, and finally you get it here minus 2 dou u by dou x, dou v by dou y plus dou w by dou z must be equal to 0. So ये हो जाएगा minus 2 and dou u by dou x, इसको x के रेस्पेक्ट में डिफरेंशिएट करेंगे, ये टर्म कैंसिल, ये टर्म कैंसिल, 5x डिफरेंशिएशन इज 5, y के रेस्पेक्ट में मींस दिस इज ओनली 5, 6x and 9z will be 0, and 3x 2y 0, so only lambda will be 0. So lambda is equal to, you get it here, 10 minus 2 means 8, bring this side, it's a minus 8. So I can say that the option number is right. We have a next question. यहाँ पे हम लोग देखते हैं, a compressible fluid is flowing steadily through a pipe, okay, whose area is decreased by 40% from section 1 to 2. So a compressible flow है, area is decreasing, means I should make some different diagram. ये नहीं होना चाहिए. Different diagram means इस टाइप का एरिया बनाना है. यहाँ पे ये सेक्शन 1 कंसीडर करते हैं, ये मेरा सेक्शन 2, whose area is decreased by 40% from section 1 to 2. यहाँ पे एरिया अगर हम कंसीडर करते हैं A, तो 40% से डिक्रीज कर गया, मींस 0.6, 60% एरिया बचा at section 2, and 60% means it's a 0.6. It is further known that the corresponding reduction in density is 15% compared to the velocity. Density is 15%. Compared to the velocity of fluid at section 1, the velocity at section 2 increased by a factor of 1. यहाँ पे वो density भी varies कर, density is also decreased by 15%. Reduction. तो अगर यहाँ पे density rho है, वो 85% हो जाती है. वाला rho था 15% रिड्यूस हुआ, इट मींस 85%. तो मुझे फाइंड आउट करना है कि वेलोसिटी एट सेक्शन 2 कितना फैक्टर से बढ़ गया. सो यहाँ पे हम लोग अप्लाई करेंगे, अगर स्टेडी फ्लो है तो हम लोग के पास मास फ्लो रेट है, ρ1 a1 b1 must be equal to ρ2 a2 b2. So ρ1 is rho, a1 is a, b1 is b1, and ρ2 is a 0.85 rho, a2 is a 0.6 a1 a and b2. यहाँ पे rho a get cancel. If you do the calculation, then you will get it here v1 by 0.85 into 0.6. If you do it this calculation, you will get it here 1.96 v1. And I can say that the velocity at section 2 increased by how much factor? it's a 1.96 factor, or we can say that it's a 96% से बढ़ जाएगा velocity. So आज के लिए हम लोग इतना ही रखेंगे. In the next class we will discuss the acceleration, rotational velocity, how will you find out, and what are the types of acceleration are there, and also we will discuss the velocity, potential function, stream function. That's it. Thank you.